Welcome back to linear algebra. We're going to jump into Anki to start off with 7. All right. What are the two matrices? What are required for two matrices to be equal? For two matrices to be equal, they've got to be this exact same size, and each corresponding entry must be equal. What is required for a sum or difference of matrices A and B to be defined? A and B have to be the same size. What size requirement must be met for the matrix product AB to be defined? The number of columns in A must be equal to the number of rows in B. What are the entries on the main diagonal of n by n matrix A sub ij? A1 A sub 1 1 A sub 2 2 A dot A and n. What does it mean to state that a matrix has size mxn? It's got m rows and n columns. What is a linear combination of matrices? A linear combination is essentially a long sum of matrices, each being multiplied by a different scalar. Doesn't have to be necessarily long. All right. They do have to be the same size though. Write out the matrix representation of a symbol. Okay, A sub ij 3 by 4. So it's gonna have 3 rows, 4 columns. I think it's gonna be A11. This is the top row. A11, A12, A13, A14. Second row, A21, A22, A23, A24, and then row 3, A31, A32, A33, A44. They say A34. I meant A34. I understand. Okay. All right. That's 49 days in a row we've done Anki. Okay. I mean, it wasn't that we missed the other days, we just didn't have any flashcards due. Otherwise, we'd be on a streak of like 150. Not quite, maybe 110. All right. I'm going to grade the work we did yesterday, and then I'll be back after that. All right, I'm not going to spend so much time going over the things I got right, but I did miss something, and this is a big learning opportunity. I missed this calculating matrix A to the -3. It is not this. It is not A3 to the -1. What it actually is A to the -1 3 times. So that's good. I'm going to keep working on problems now. I'll talk to you in a bit. All right. This one was good. We were showing that this is from yesterday. A squared equals I 3 by 3. So basically I just put in variables because they gave a hint to use zeros as the non-main diagonal. Solve that. That just ends at a squared b squared c squared equals 1 1 1. So we know that A, B, and C are all either plus or minus 1, and then just through different permutations, you're going to get the 8 different matrices they're looking for. This one was like asking a question of if a matrix with 2 identical rows or 2 identical columns will have an inverse. I don't know what that means. We've only learned 2 by 2 matrices, so wouldn't 2 columns that are identical? Oh, these are 2 identical columns. Okay, yeah. No, it won't, because the determinant will always end up being 0, because you're ultimately taking 2 numbers and multiplying that or subtracting from each other. This one was a little interesting. This is manipulating this to simplify this expression. I don't know if I did this right. I think this is right, yeah. Inverse times another matrix it's not the inverse. These are going to cancel each other out and become I. Then I think when you have it to the power of the inverse, you actually take them and flip the order. And then in that case, a and negative a are next to each other. I don't know if I can do that. If we can decide, hey, we're going to do a inverse of a in the middle rather than ca first. Anyway, that'll be a good learning one. And then the next problem we're going to start is showing that why this is true for all numbers n, all integer values of n. So that's kind of difficult. It's almost like a proof. How could we show this? How could you show this? You got a scalar times a matrix, and that's going to be to the power of n. Oh. I think I can do it right now. Look at this. K times A, K times A, K times A, dot, 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 n times. And ultimately, through this is the associative property of scalar to matrix multiplication. Meaning we just take these out. Okay. I mean, check that out. 3 steps. We expand this. That's just expansion of what it means to be the exponent. And then we say associative property of scalar slash matrix multiplication, meaning we can just take the parentheses off. So it's this. And then we can just reorder them, k to the n, a to the n, because of the commutative property of scalar slash matrix multiplication. I think that's solid. All right. That's it for today. Talk to you tomorrow. See you.